Today, I would like to talk about two studies currently we are working on. One is pharmaceutical and personal care products, PPCP, in the reused water. Another is biochar. Water reuse is a feasible and economical water recycling strategy. Using treated wastewater for land application can provide nutrients and reduce high-quality water use. Currently, there are three primary wastewater for reuse. One is from industry and sewage treatment plant. Second is from rural community. Third is from large animal farms. In the big city, we have a large-scale sewage treatment plant to clean up our generated wastewater. After three-stage treatment, the water can be reused for the irrigation. In a small town, aerated lagoons are used to treat domestic wastewater for rural community. Usually, the treated wastewater is directly charged to the surrounding creek. In large animal farm, like a dairy farm, swine farm, they generate large volumes of minute contaminated wastewater. Typically, this wastewater used as fertilizer for the agriculture land application. This wastewater, even after treatment, they still have a lot of contaminants. Currently, we have two funded research related to the PPCP causing from the wastewater reuse. So currently for our PPCP research, mainly focus three areas. First is the PPCP environment monitoring. We develop a robust analytical method to detect the PPCP at extremely low level, like a nanogram per liter. Then we invest their environment feed and transport. For example, after wastewater reuse, how this PPCP relates to environment, how they reach into groundwater, around the surface water. Third is pollution prevention. Based on our research, we will develop feasible efficiency and economic strategy to minimize negative effect causing from the wastewater use. My second study is for the biochar. So what is biochar? Biochar kind of like a carbon, charcoal, but the biochar must be made from biomass. Biochar made from the waste biomass can provide 5 valuable benefits, like waste reduction, energy production, carbon sequestration, soil amendment, and pollution treatment. If we use the pyrolysis to convert waste biomass to 3 valuable bioproducts, syngas, bio-oil, and biochar. So this conversion process including waste reduction and energy production. Actually, biochar is designed for carbon sequestration because biochar is very recalcitrant to degradation. So biochar can persist in the soil for 1,000 years. If we use the pyrolysis to convert the waste biomass to the biochar, and store so we can lock the atmospheric carbon in the charcoal and install the soil for long term. So the whole processor is carbon negative. Once biochar uses soil, they can improve the soil quality because biochar kind of like a sponge. They can trap the moisture, holding the nutrients, attract the beneficial fungi and the microbe. Actually, biochar is not a new technique. Biochar use came back to 1,500 years ago. At that time, the people at the Amazon, they buried the charcoal in the soil, improve the soil quality. So scientists find rich soil in this area. Also, biochar is can serve like active carbon. They can absorption and remove a lot of inorganic and organic contaminants. We found that biochar can absorb ammonia and phosphate, iron, this chemical fertilizer. Then we conduct a field and greenhouse experiment. Use biochar as a soil amendment. We find we use the biochar can reduce chemical fertilizer use, also keep seed yield. Also, right now, we are Istc still involved several biochar research. For example, design the biochar and address potential biochar application issue like a PAH. Thank you.